Okay, so we are lesson 3.5.2 is what I labeled it. If you're in your notes, lesson 3.5, flip to the second page, right? And the second example down says using substitution. Can everyone find this example? Because that's where I need everyone to be together. Okay? So, with that in mind, okay, last week, and hopefully those of you that are quarantined have watched the video, tried to figure out this whole lesson 3.5, the first part using elimination. Okay? I know you got lots of emails from me. Well, maybe not lots, but you did get emails from me, didn't you? If you checked your emails. So, today's using substitution. Now, moving out from today, you'll have a choice. As you look at a problem, does it look like a good elimination problem to you? Does it look like a good substitution problem to you? Or Alexis absolutely is not happy with elimination. Maybe she's going to like substitution better. Okay, to me, there's certain problems that are better for one than the other. So, okay, so substitution. Think back to when we did substitution with two equations, right? What was your first step in substitution with two equations? Because that's the same first step now.
Get a variable by itself.
Okay, so when we had two equations, it was pick one equation and solve for either x or y. So we had to make it x equals or y equals. Okay, difference. Today we have three equations, which, by the way, I'm going to number these 1, 2, and 3. And that is, if you are totally out of the loop and haven't been watching stuff with me lately, that is purely just organization purposes. Okay? Now, as we look at these, is there one of the equations that would be easy to solve for either x, y, or z?
2.
2? And why are we picking 2? I agree.
X is already.
Okay, so when we find something that we want to solve for, because there's an x, a 1x, that's why it's a good reason, right? Because there's an x that just has a 1 beside it. So what I'm going to do, okay, I was trying to remember how I set up my notes. First of all, I'm going to write a note here that we are going to solve an equation for x, y, or z. In this particular case, you guys picked 2. So I'm going to write 2 down here. How do I solve this equation for x? If it's x plus 5y, to move that plus 5y, we're going to subtract 5y. So, if I subtract 5y here, I'm going to subtract 5y there. Rewrite your equation now. We're going to have x, 5y's cancel, equals, what do you guys want to say x is equal to?
Minus 5y.
Not sure, I might have heard both options there. And this is a choice, right? You could say 9 minus 5y if you want. Is that what you're saying? That's what you want?
It's prettier, so yeah.
That's what we all want.
Or we can say negative 5y plus 9.
I like that one.
Now, and here's the deal. In this situation, I could go either or. The only time I'm picky about that kind of stuff is when we're trying to get y equals mx plus b form. I'm not trying to get y equals mx plus b form today. We're not graphing this. No way, no how. We're not graphing x, y, z then, okay? So, with that in mind, we are just, it's whichever one you want. I'm going to go with 9 minus 5y. Now, if you want to go with the other, you'll be fine. I promise. You'll be fine. It's doable. Okay. So now, we have one equation that is either x, y, or z equals. In this case, it's x equals. think back to regular substitution when it's two equations. What do we do once we get it to be, in this case, x equals, Kylie?
We plug it in.
We plug it into, normally we say, the other equation. This time we're going to have to take turns and we're going to end up plugging it into both other equations is what's going to happen. Because what we're trying to do is we're trying to get down to just two variables. We're trying to get two equations down to just two variables. So, with that in mind, I'm trying to think, yeah. Shall we start with 1 first?
Let's do 3.
3.
Where's the y gonna go on for me?
Because we already did 2.
Well, here's the deal. We're going to have to do both. So I'm going to go number order, and I'm going to do 1. So, 1 originally says 2x plus 3y minus 2z equals negative 1. I'm going to write that out first. 2x plus 3y minus 2z equals negative 1. Every place I see an
X.
x, we're going to put what in? 9 minus 5y. I don't know if I helped or made a mess there. So it was 2x plus 3y minus 2z equals 1. I see an x, so I'm going to plug it in. So now I'm going to write 2. Instead of x, I'm going to write 9 minus 5y, or negative 5y plus 9, if that was the route you took. Then what do I need to continue writing?
3y minus 2z.
Plus 3y minus 2z, ooh, thank you, equals negative 1. And I say thank you because I had not written my negative on my previous line. Which means I would have sent this problem spiraling downward real quick. Okay? So, now, clean this up. Okay? Clean this up. What do we do with the 2?
Distributed.
Distribute, good. 2 times 9 is 18 minus 2 times 5y, 10y. We still have plus 3y minus 2z equals negative 1. The type form we need to go for, or at least my recommendation, is to have the variables on one side, constants on the other side. Okay, so as we look at the left, what can I clean up first of all? Okay, I heard 2 different things I can do. They're both good. I was looking at,
Combined with 3.
what do we know about negative 10y plus 3y? Yeah, so if I go ahead and just carry down the 18 for a moment, it becomes minus 7y, still minus 2z, equals negative 1. And now if I want just a nice equation to work with, not going to be great because we're going to have negatives, but how do I get 18 to the other side? We're going to subtract 18. If I subtract 18 on one side, subtract on the other side, what equation do we have left? Okay, negative 7y minus 2z equals negative 19. Okay, guys, take a wild guess what I'm going to call this.
4.
4.
This is equivalent to equation 4. Remember we're doing this last week? Okay, I'm going to call this equation 4. Now, equation 4 has a y and a z in it, right? I want to get another equation with a y and a z in it. So, in order to do that, we're going to repeat the process we just did. We just took 2, this x equals 2, right? And plugged it into 1. We're going to repeat that process and take this x equals and plug it into
4. 3.
3. Okay? So, let me write out what 3 is. 4z minus 5x equals 4. Every place I see an x, what are we going to replace it with? 9 minus 5y. So, we're still going to have 4z minus 5 times, what's x? 9 minus 5y equals 4. Clean up. What do I do with these parentheses? We're still going to distribute, right? So we're going to take this minus 5 and distribute. I guess I should have said we're going to take, what is it we're going to distribute? And it is a negative 5, right? So I'm going to say 4z minus 5 times 9 is going to be minus 45. Minus 5 times minus 5y is going to be plus 25y equals 4. Okay. Equation 4 over here was a y term, a z term equals a number term. Go for that matching form.
And I need to add over.
Okay. If we have a minus 45, we can add 45. So then I have 4z plus 25y equals 49. If you haven't already, there's one other little housekeeping thing I do with this number, or with this equation. And we're going to be putting 4 and 5 together in a moment if you don't see that coming. And notice what order is 4 in? Y and then z. So we want to be consistent. What order would it be good for this equation to be in? Y then z. Unless you switch the other one. The point is I want them to be in the same order. So I'm just going to flip this around and say 25y plus 4z equals 49. What am I going to do? I'm going to call this 5. Okay. I would like to make the statement that's the hard part. Because from here, we're going to do exactly what we did last week. Once you get equations 4 and 5, we're going to put those together, and we're going to do the math there. Now, here's the deal. If you're not liking the substitution stuff, good news. The rest of the problem, I don't actually continue with substitution. I'm going back to my elimination methods. Okay, so let me, trying to stay organized here. Write 4 and 5 on top of each other so you can see what they look like. So equation 4 is what? Negative 7y minus 2z equals negative 19. Equation 5. 25y plus 4z equals 49. Okay. Well, with that in mind, think elimination, guys. Would you prefer to eliminate y's or z's?
Z's.
To me, z's are a no-brainer here. I do not want to get 7 and 25 to be the same. However, a 2 and a 4, even better, it's a negative 2 and a 4. How do we get those to be? Well, okay, we want them to be the same number, opposite signs, yes? They already have opposite signs. So how do we get 2 to become 4? Times by 2, right? Okay, so we're going to times by 2 here. We're going to times the top equation by 2. The bottom equation, I would say keep it as is. Now, do I have room to do this to the right here? Maybe. When I multiply that top equation by 2, it becomes negative 14y minus 4z equals negative 38. By the way, I'm not going to feel sympathetic for you with big numbers because you're allowed to use a calculator, right? So, no sympathy there. The bottom equation, I'm just going to rewrite it. 25y plus 4z equals 49. What am I eliminating? The z's. My z's have a minus 4z and a plus 4z, so how do I eliminate opposite signs? We're going to add. So you're going to add your two equations together. This is something, those of you that haven't taken the quiz, this type of problem you could see on the quiz, right? This is old news. This is what you could see on the quiz, those of you that need to make that up. Okay. Negative 14y plus 25y. 11y. Negative 4z plus 4z. There's the 0, the cancel we want. Carry my equal sign down. Negative 38 plus 49. 11. Well, that gives me confidence I've done something right. Are we good back there? Okay, that makes a difference, doesn't it? Okay, finish this off, right? 11y equals 11. Divide by 11, and y is 1. Still the same as last week at this point, right? Once you know one of them,
You can plug it in for your
you go back and start plugging it in, yes?
Yeah.
So, normally I say go back to 4 or 5, don't I? And here's the deal. I'm probably going to stick with 4 or 5 just to keep, things nicer there. But you technically could also go back to equation 2 in this case because it's x and y only. Okay? You need to go back to something that has a y and one other variable. Okay? Oh, actually, I forgot. What can we go back to? What happened to our solved version of 2 here that I forgot about? Could we go back to x equals 9 minus 5y?
Yeah.
Yeah, and actually, is that what I've done in the past? Yeah. Okay, so there's a couple different options you have here. I totally spaced it, but you can go back to 4 or 5, or this equation 2 that was x equals 9 minus 5y, except what's y? Y is 1. So, x equals 9 minus 5 times 1. Big math, 5 times 1 is 5, and 9 minus 5 is 4.
Dang.
Okay. I have y, I have x, I need
Z.
z. What are options for going back to find z?
Number 3, so it does not have y in it.
5.
Okay, so my options are 1 or 3 at this point, because I need something, in order to find z, I have to have something that has a z in it, don't I? Now, I agree, number 3 looks a little easier than number 1, doesn't it?
One's easier.
Huh?
One's easier, man.
One's easier math, you think
Like
so?
easier.
Yeah.
Oh, okay, well,
4 times 5 is negative 20.
I'm going to use equation 3, which says 4z minus 5x equals 4. So 4z minus 5 times 4 equals 4. 5 times 4 is 20. So 4z minus 20 equals 4.
4z.
If it's 4z minus 20, I'm going to add 20. 4z equals 24. Divide by 4, and z is 6.
Yeah.
How do I write my final answer?
416.
Ordered triple?
Order triple 416.
416. In other words, you are going in
XYZ.
XYZ order, yes? Turn around, Cam. Okay. Now, I am not as good at suggesting you guys check yourselves as I should be. But if you needed to or wanted to, how could we check to make sure that 416 is the correct answer?
You graph it.
Graph it.
We're not graphing 3D. 416. Plug it into equation 1. Does it work?
Yes.
Plug it into equation 2. Does it work? Plug it into equation 3. Does it work? If 416 works in all three, then it's good. Okay? If it doesn't work in one of those, then you might have a problem. Okay? So it's just kind of a reminder thing. As I said, I don't usually take the time to check. Sorry. Okay. Questions? I know, it's big. It's a lot, right?
It is a lot.
Okay, we ready to try the next one?
Let's go for it.
Okay. I've got to move my screen, so. Ouch. Okay. Try that again. Okay. Name of the game is substitution. Pick one equation and do what? Pick an equation to solve for x, y, or z. Preferences?
3.
And I agree. Why are you guys suggesting 3? Okay, because you have a 1x by itself. Why didn't you pick equation 2? Why'd you pick equation 3 over equation 2?
It's longer.
Okay. I heard it's longer. Okay. Here's the nice part is it's x plus 2z. We already don't have a y, so it makes it a little bit shorter problem there, doesn't it? Okay, so I like that. Let's go with the equation. We called it equation 3 because you guys are smart cookies like that, but there we go. I labeled equations 1, 2, and 3 now, didn't I? Okay, so equation 3. X plus 2z equals negative 8. How do I solve this for x?
Minus 2z to both sides.
Okay. We're going to subtract 2z. So x equals,
Negative 8 minus 2z.
and if you don't like their answer,
Negative 2.
negative 2z minus 8. And in this case, it doesn't really matter either way, does it? Either way, you leave with a negative. So I'll go the negative 2z minus 8 on this one.
Thanks.
Okay. So I picked one equation. I solved it for x in this case. Now what do? Plug it into the other two equations, right?
I just have a question.
Uh-huh.
Can you just plug into, why can't you just plug into the third equation?
If you plug it into itself, everything's going to cancel out. You can't plug it into itself. It has to go into the other two.
It sounds like an easier idea.
Well, it will bring a quick end to this problem. Not the correct end either.
Maybe I want.
Just realize, are you going to see this on the test?
Yes.
Yes, this is something we need to learn. This is in our standards, okay? But yeah, because if you go and plug that in, you end up probably getting all the variables cancel out and you get 0 equals 0. So,
No solution.
actually that's infinitely many solutions, but yeah, it doesn't work real well.
We're on the right track. Just throw more.
Okay, so take 3, plug it back into I'm gonna do 1 first. I don't care what you guys do first.
1.
She's sassy today.
Am I sassier than normal today, I take it? We gotta try and meet your guys' sass, right? No? Okay. Okay. 2x. Every place I see n, x. We're gonna replace it with that right there. Okay, so 2 times x, except x this time round is negative 2z minus 8. Copy the rest of the problem. The rest of the problem is minus y plus z equals negative 2. Okay? Mathematically, what do I do here? Distribute first. When we multiply this 2 in, 2 times negative 2z,
Negative 4C.
negative 4z, 2 times minus 8,
Minus 16.
minus 16,
Minus 1.
still minus y, still plus z, still equals negative 2. I didn't change anything there. Okay? 2 other steps that we have to take usually. One of them is look for like terms. In this case, on the both on the left side are a negative 4z and plus z. What's negative 4z plus z? Negative 3z. I still have minus 16 minus y equals negative 2. Okay. We need to get the 16 over to the other side. So if it's minus 16,
Yeah.
we're going to add 16. So then I still have negative 3z minus y equals 14. And this is where we have a couple different options. What am I going to call this equation? Okay. I'm going to call this equation 4. And I'm fine with leaving this order, although what's unusual about this order?
It's not Y.
It's not
aligned with number 5.
it's not alphabetical, is it? Okay, it's ZY instead of YZ. Okay, and here's the deal. We haven't made equation 5 yet, have we? So you have an option. You could leave it in this order, or if you prefer, you could flip it. Now, here's the thing. You don't know what's going to work out next, but just for the record, if we flip this, what's negative 3z minus y become?
Negative 1 minus 3z.
Negative y minus 3z equals 14. And I know a little bit about how this problem works out. And the way my next problem works out, it tends to work out zy also. So that's why I said you can leave it like that, or we can just go yz. Okay. That was equation 4. We also need to create equation 5. How do I create equation 5? Take your x equal equation, right? Which was equation 3. We plugged it into 1.
Plug it into another equation.
What do we have to plug it into now? 2. We have to plug it into 2. So if we plug it into 2 here, 2 is x plus 3y minus z equals 10. Every place I see n, it was x this time, right? We're going to plug in what we had over there. So we're going to plug in the negative 2z minus 8. I said, that's not what you said, was it?
Oh, I was looking at the last one.
Okay.
I was like,
Let's stay on this problem. So instead of x, I'm going to say negative 2z minus 8, still plus 3y,
Y minus Z.
still minus z, still equals 10.
Why you?
No distribution this time.
Now we can combine like this.
We can go to like terms. Negative 2z and minus z. Negative 3z. Still minus 8. Still plus 3y. Still equals 10. What has to happen? It's minus 8. Let's add 8. So negative 3z plus 3y equals 18. And you can stop right there, can't you? Okay. You can stop right there. And what am I going to call this? Equation 5. However, if that whole zy thing is bothering you, you could instead flip this and say 3y minus 3z equals 18. Okay, your choice there. The key is you need them in the same order. Okay. And now we pick up on the same process we were doing last week with elimination.
Yep.
We have equations 4 and 5, which 4 is, I'm going to say negative 3z minus y equals 14. And 5 was negative 3z plus 3y equals 18. What are you going to tell me to do?
You're gonna multiply. Multiply 4 by negative 1.
One of these two equations multiply by negative 1. Okay, whether it be 4 or 5. Because they both have 3 z's, right? That's good. But they both have negative 3 z's. Math works better if we have the opposite signs. You guys are less likely to make the mistakes. So we're going to multiply, I think I was told the top one by negative 1. Officially, it doesn't matter though, right? So when I do that, this top equation becomes positive 3z plus y equals negative 14. Other equation carries over as negative 3z plus 3y equals 18. 3z's have opposite signs, add. 3z plus negative 3z, cancel. Y plus 3y, 4y.
Y.
Negative 14 plus 18, 4. If 4y equals 4, divide by 4, and y is 1. What's my recommendation of what to do with that y equals 1?
Plug Y in for X.
I like to go back to equation 3, the solved form of x equals negative. Whoops, we can't do that here, can we? Okay, forget what I was just saying. I was trying to be quick and I ruined it. Okay,
Alright.
y equals. This time I have to go back to
8, 4, 5.
4 or 5, don't I?
You can plug in.
So if I use 4, negative 3z minus y, which is 1, equals 14. Negative 3z, you have to add 1. Negative 3z equals 15. What do we do? Divide by negative 3, and z is negative 5. Now could I go back and use my equation 3?
Yes.
Now I could. So now I could say equation 3 X equals negative 2z minus 8. X equals negative 2 times negative 5, hold on, minus 8. X is 10 minus 8. X is 2. Final answer.
2, 1, negative 5.
2, 1, negative 5, she says. Is she right?
Yes.
Okay, good deal, because I didn't check my order. Okay, the one other problem I wanted to do was practice a word problem setup. You might have a word problem in homework, so we might have to go back and talk about that. But yes, you have an assignment. Do it tonight. Got it?
Yes.
Okay. And if you have a quiz to make up, stop and talk to me before you leave, please.